All right, so first thing that we didn't get a chance to do when we did our quick once-over on Monday, one of the few things that I think, so a couple things I want to do. One is take a little closer look at some of these assets, one or two of them, just to kind of, so you get the full scope of what's in a kind of professionally made particle system. And then make a real simple one ourselves, kind of A to Z, and then talk over the assignment for next Friday. And then, time permitting, anybody who wants to get checked out today, I'll try to do that. Okay? Sound all right?
Sure.
All right, good. So first thing I want to say is you should realize that a particle system that looks really good. Now this is kind of too much to see almost when I turn it on here. But if you look at like the fire that comes up over here, so that's a professionally made fire. Now when you look at it, you see there's a bunch of different elements to it, right? I mean, that is not one particle system. I mean, you pull it out as one asset from the standard assets, but when you actually go and look into it, no big surprise. I mean, that's fire complex is that one. When you open that up, look at what's inside of it. 1, 2, 3, 4, 5, 6, 7, 8. 8 things. Okay, one I think is just a light, because fire should shed light, right? It would be kind of weird if you had a fire, it looks nice and bright, and all the objects around it are still jet black, like there's no lighting in the scene. Okay, but all the rest are particle systems. So if you haven't gotten it already, by looking through this, you might get a better feeling for what some of the art is, behind making these things look good. I mean, I don't even know why there's the number that there are. There's no standard way, right? I mean, people look at this with their eyes and realize, oh, that's not quite right, and then they fix it by adding in yet another particle system. Now, we can actually click through these one by one, and if I actually let's do this. Let's zoom in so you can see it as good as possible. Let's take our camera and tell it to sync. Okay, there we go. So now I can go and I can say fire. You can kind of see what the fire is. Okay, so that already, I mean, if I were making this myself, I might stop there, right? It's a fire. What more do you want? Okay, but clearly doesn't look anything as nice as the final solution. So if you click from fire, or what's the difference between fire and flame? Okay, so these are like much more photographic looking flames. So those particles are probably actually originate in, I was going to say photographic imagery, because that would have been the case in the day, but actually these days we can do that good completely in simulation, but a simulation that would not be running live when your user is doing their training, or when your user is playing their video game, okay? It's a simulation that's real slow, so you run it offline, you capture the images as like a little movie, right? And then they're getting played back here. Right? So if you actually,
So it looks like they just have an extremely large particle size that probably has like some type of material.
Yeah, well, we can let's see what we can learn from it. So here's flames over here. If we look, we're going to know about the material. Okay, you see, look, what do you make of that material? What do you think that is? That is the movie, frame by frame, of the flames. Okay? It's all in one sheet. That's sometimes called an atlas. Okay? And that's an optimization that's used a lot in particle systems. If you're going to be using a lot of different textures, you might not be using them as a movie. You just might, it might be your bullet hole. You don't want every bullet hole to look like every other bullet hole. So you go and you make, 20 bullet holes that are ever so slightly different. You line them up on one texture like that, called an atlas. Now, obviously, when you bring that in, there has to be a tool. Surprise, surprise. There is a tool to let you go and say, okay, here's image 1, and here's image 2, and here's image 3 inside of the image. Say what the bounds are. Okay? And then there is a cost savings computationally to loading that in just as one file, one image file rather than many image files. Okay, so that's what's going on with the flames. I do not expect work like that from you when you create things from scratch. Okay, we've got, actually, let's tell the flames to stop. and let's tell the fire to stop so we get rid of it. Okay, okay, now we can go to glow. All right, now this one's kind of subtle. Wow. And in fact, with the way it's set up, I can see nothing. Can you see anything going on there? Let me rotate my eye around here to the side so we can. Hey, all right, great. Please don't do that. Okay, let's get over here so you can see it against the blue sky. So you'll see. No. There actually is something happening. Okay. Camera Control Shift F is this lock camera to view. Okay, let's try again. Glow. Okay, can you see a little bit of distortion going up here? It's there. Okay, so I mean, this is just to show you that, yeah, I don't even know if you gave me with and without, I might not even pick up on that there's any difference. But some artists thought that was important, and you know what? Given how good a lot of these artists are, he's probably right. He probably knows that actually will give you more of a feeling that it's a real fire. I think the idea is that it's some kind of internal lighting from the flame. So like when there are sparks. Oh yeah, there's sparks. When there are sparks getting thrown up by a fire, they are also they're light sources, right? It's a light source in some smoke. So it basically makes it kind of a glowing cloud. That's part of what's happening above your fire. So here they're faking that up with an actual ever so slightly glowing cloud. Okay, there is some black smoke getting thrown up. There is some, okay, what do you think? Smoke dark, smoke lit. What is going on here? Okay, what's the difference? Okay, here we go, let's do it again. Okay, here's smoke dark. I don't see that it's orange. Oh, maybe slightly. Okay. So usually lit, what does lit mean to a computer graphics guy? Kinda, but you're thinking of emission. So something that actually looks like it's luminous is an emissive material to a computer graphics guy. What does lit mean versus unlit? Unlit does not mean dark.
It would have some reflection to it.
We're more like reflection to it. It picks up your scene light. That's the point. Lit by the lights in the scene. Unlit means unaffected by the lights in your scene. So ironically, something that's supposed to be glowing like a neon light will be unlit because it should not be affected by the lights. It should be glowing and bright no matter what the external lighting is. Okay? All right. So there you go. So probably some of that smoke is meant to actually pick up. So let's say I had a big neon sign, speaking of neon signs, right there next to the fire, and it's set up as a light source. So it's everything else is turning green. This is the green neon sign around here, but the smoke stays the same color. That would look weird, right? So we have lit smoke that will actually pick up that green, so it will, fool your eye a little bit better. Okay, what else? Sparks falling. You get it. Sparks rising. The light, of course, is just the light. All right, let's look at the whole thing again, all together now. All right. Actually, I think I have to actually play it so I can see it again. Now you see. Now you appreciate what that thing is. It's a lot of things, but it looks like one prefab object that you just plunked down. Now, additionally, one of the things I noticed looking at the more complicated examples that they have is that they also have a little bit of scripting. And not very much. And honestly, if I were to do that, even if I went to all the trouble to put in all those layers in that particle system like they did, I don't think I would bother with the scripting. But for actually doing it, especially if you're thinking, hey, I'm building a fire, I'm not, so in a game shop or in a good 3D simulation shop, they're organized in a certain way. The guy building the fire is not the guy who actually places the fire down in a scenario to actually be visible to an end user. That's not his job. His job is just to make the fire. There's another guy called a level designer who actually goes and figures out the geometry and, oh yeah, the starting forces start here, and here's the objective, and the hill looks like this, and I need some trees down here, and here's the campfire. Okay, he's the guy who places the fire. The guy who builds the fire, therefore, doesn't know how big the fire actually needs to be, how it should be scaled in the end scene. And so that's the purpose of this code, among other things. Some of it has to do with timing as well. And some of it, I think, is kind of poorly done. But this is, again, is that like a demo object. So I don't think Unity is not really meaning to give you the ultimate fire or explosion, but they're just kind of trying to show you how you actually could possibly do that. Okay, if you look at the fire, again, I got to stop it because the fire kills itself over time. All right, if you look in here, you see there are a couple of different scripts in here. One is this destroyer. This is what's making the whole thing go away. So what they're demonstrating with this is, okay, fine, if you actually build the particle system out of 6, 7, 8 layers to make it look realistic, now you've got an issue when you want to get rid of it. And it's not one thing to go away, right? It's 6 or 7, 8 different things. Okay, not only do they each need to be deleted, but you maybe want to be a little careful how you delete them so it doesn't too abruptly go away. So in other words, if there's a fire in a barrel and, again, back to like what I have, you spray water on it, the user sprays water on it, the fire goes out. Okay, when a fire goes out, the smoke and the sparks that are immediately over the barrel do not immediately wink out of existence. They continue on and they dissipate. So what you would see in that script is it actually looks at each one of those 8 layers and says, how long do each of your particles live? What's the max value for that? Okay, so I will kill you and I will remove you from the scene, but I will allow that max window of time to let any particles that you've created die a natural death, so to speak, fade out, rise out of the scene, whatever you're supposed to do, and then I'll remove you. Okay? And likewise down here, this is the thing that's can do scaling for you. So if you go in here and you say, no, not 1, but 10, and then run it, it's a bigger fire. All right. Now the last thing I wanted to show you is just something that I thought was really cool. This was a learning point for me. Let me bring the camera back, kind of more or less where it was when I opened it. Where is the plane? I want the camera more or less like I had it. That was it. All right. Control Shift F. Ew. Where did my plane go? Oh, okay. I oriented the plane instead of the camera. Silly me. All right, let's grab this. Okay, that's good. Control Shift F. All right, there we go. All right, so I didn't point this out before. A lot of you probably already noticed it. So what's this thing here? This is just your plain old garden variety cube that I just created in 2 seconds and left in its natural form, actually sitting just about at the origin where it's born. Why did I do that? Okay, if you didn't notice, watch what happens when I start the scene. Where's the cube? Did you get it? Is it too fast? Let's look at it from this angle. Camera. Control Shift F. All right. Let's see if it's any better. There it goes. I don't know why. It's kind of a weird trajectory. Oh, no kidding. Oh, that's interesting. Okay. Wow. All right. Yeah. So obviously it's this explosion that's blasting it out, and then it's getting hit by the afterburner. Okay, that's really weird. Okay, so I guess they want the afterburner to be able to bend trees and stuff like that, or something like that. I have no idea what they were thinking about the afterburner. But so there's actually some really interesting code in there to go and figure out. So the cube is not hooked to the explosion in any way. What happens is in the explosion, let's just take a quick look. I'll leave it to you to follow up on this as you like. But if you look at the explosion here, explosion physics force right here. If you bring this up, there's some interesting stuff here. So they have like a call here, physics overlap sphere, okay, where you basically give a center and a radius, and it finds all of the objects that have a rigid body on them, i.e. are set up to be physics, to be affected by forces. It finds all those objects and puts them in a list to you, which you then can iterate through, okay? So what it's doing is it's finding, I'm not sure I'm representing this 100% correctly, but then it's iterating through these guys and applying a force to some of them at least. Seems to be 2 layers of this. The overlap sphere is giving back this thing COL, so I'm not sure what COL stands for. And then we're iterating through COL and finding the rigid body. Oh, COLs are things that have colliders on them, probably. Okay? Yeah, because just if something has a collider. So, okay. So, apparently what this is, let me do some educated guessing here. Probably the only thing that's supported, this is already very cool. You can go and ask for all physics-savvy objects, but physics-savvy objects come in 2 forms, right? There could be things that just have a collider, and then there are things that actually have a rigid body, meaning that they're meant to be moved by physics, okay? So you get all the physics-savvy objects, but then you have to sort through and pull out the ones that actually have rigid bodies. Those are the ones you go and apply a force to, and boom. So you could actually go and, with cubes, build up a whole little house or something there, and then when your explosion goes off, it could be kind of cool. All right, I thought that was kind of neat. All right, so that's most of what I wanted to do, except let's just try building a little particle system. Boy, I'm glad I only have 5 things on the list. I don't know if they're 5 particularly easy things, 5 things on the list for next Friday, but it's probably plenty. It's a little bit unwieldy. And I've done this before, so it's been a year, but it's quite a bit of hunting involved, at least for me still, to go figure out which button, which slider, whatever does what I need it to do. Okay, so let's give it a shot. Okay, so let's go to a new scene. Create. There it is. Okay, new scene 1. All right, so in new scene 1, probably didn't want to do that. Doesn't matter. All right, new scene 1. Good, so let's make a particle system. All right, to get started is really easy, okay? You just do game object, effects, particle system, there it is. Now why is coming out black? I have no idea. That's kind of interesting and weird. But let the hunt for the parameters begin, right? To actually make it what you want to make it. Okay. Now, what you're going to need to do is, even for my modest list for a week from Friday, you're going to have to create at least 1 texture. Again, when you go in and you make a new image, it doesn't have to be super big. You can be very modest in size. Square is usually the appropriate thing to do for a particle system, right? But you do want to go to advanced objects and start yourself off with transparency in your background just to avoid all the fiddliness of fixing that retroactively. Okay, so I've got some kind of a particle here that I wanted to be like some rubble of the nature. That's actually one of the things I'm going to ask you guys to give a try to for next week, see how hard it is. So there you go, some kind of irregular darkish thing. That would be some detritus that might be kicked up by an explosion or something like that. Okay, created it, exported it as a ping, dragged it over into the into Unity here. Remember that you have to go and click alpha is transparency for something that's a particle. Okay, there you go. And then the next thing I went and did is I created a new material. Well, let's do that part again. Create material. Okay, let's say new, let's say class demo map. Okay, All right, now you're probably not going to want the normal shader. You're probably going to want one of the particle shaders. You go down in here. Unlit would be for something, again, unlit doesn't mean dark. Okay, it just means you don't want the lighting in the scene to mess with the way it looks. So something like an ember, probably unlit. Something like smoke might be lit. Okay. For something like this, since it's supposed to be like a physical object, like concrete crumbling away or something, I think it should be lit. So I'm going to take standard surface. Okay, and then you can come in and you can rendering mode opaque is not going to do it for a particle. You're going to need one of the either cutout or fade. Let me try fade. Soft particles is an interesting thing. If you notice with your particle system that it's behaving strangely around other materials. So it does look really weird. Like if you have a texture that's supposed to be a puff of smoke and it's sticking half into a wall, a lot of times that real sharp edge between the smoke and the wall just looks wrong. Because smoke is not going to get, the center of the puff is going to be dense, right? And the natural smoke puff going along the wall is not going to be dense right at the wall. It's going to fade in. So that's the idea of soft particles. So if you're seeing something like that, you might want to check that box. You may or may not need your particles to be two-sided. If you're flipping them around because they're representing a leaf, and that was one of the things I forgot to put into the list for next week. Oh well. But I can't really demo it either. So it'd be interesting. So one whole class of applications that we haven't seen much of, except for the dust storm example. That was one of the ones that we looked at first on Monday. Are kind of environmental across the level, like a rainstorm would be another example, or snow falling, or dust in the air. I mean motes of dust, not clouds of smoke. Or leaves kind of floating down. Again, these are things that, why am I even mentioning them to you? They seem really minor, and they kind of are, but they're also, they're relatively easy. These are things I feel are a real good cost benefit in terms of providing the user a real sense of space and immersion in the environment. Makes the environment seem much more realistic and alive to have those things in it. And it's work, but it's not all that hard. So, I recommend them. All right. Okay, so good. So let's. So I have a material here. All right. Now the next thing is, I found this a little bit weird. If you go to your particle system, so the way you actually get the material in, there's some material information at the bottom, but apparently you don't mess with that. You go up here to renderer, and this seems to be where you stick your material in. So I've got my class demo mat. I can come up here, material, and see, look, there's trail material. Okay, now that's not working. Why is that? That's horrendous. Sorting. So something must be overriding, or did my material parameters not take? That would be the other possibility. Let's actually see what I have set here. I thought I said fade. Don't know what more to say beyond that. Let's see, the texture still knows that it's transparent. Yeah. Probably something's fighting with my own settings, right? And I think you can see I'm asking for it to be transparent, and it just isn't happening. Let's try the cutout mode, but I don't think. Oh wow, that's.
You move rubble on, or apply rubble to the beginning of that.
Apply it. What do you mean?
Like, so bring in the texture we just made.
Okay.
Rubble.
Oh yeah, I didn't stick it in. Yeah, there you go. Thanks. Yeah, that must be it. Right, so you can click here or just drag it over. Either way. Yeah, that's a stupid mistake. All right. So there we go. That should be better. Yeah, you can see it in the upper left. Now maybe I'll have better luck. All right, fine. Then let me go back to phase mode, because that's what I really like. All right, now these are huge pieces of rubble. Not at all what I have in mind. So okay, let's see if we can fix it a bit. scale it down, right? So now the hunt begins. Okay, how do you scale it down? Somewhere here should be size. Okay, start size, maybe. All right, looks like it's doing it. All right, I want it to be small. I would like them to be tumbling. I would like gravity to affect them. All right, not exactly what I want in terms of density. They're too spread out. There's a lot of things to fix. I mean, it's kind of never ending. You just keep going through and you tweak, and if you're good at this, then you get to a better solution, and you get there faster than the guy next to you. And if you're not, you circle a little bit more. What can I say? I don't find it particularly easy.
You made a volcano instead.
Well, it depends. If it's an IED or something like that, you get a volcano. Yeah. Free volcano with every IED. All right. So let's see. So, but I would like to have some things rotating. Used to be up here. I could swear there used to be rotation settings up here. Now there aren't. Think maybe you have to go down to rotation over lifetime. I don't think it's rotation by speed. Let me actually see. Could be. Let's try both. Angular velocity. Okay, I think I need more spinniness. Still way too. It seems like the speed range is not editable. That's weird. See, it seems like they're all getting affected together. Not very happy with that. I mean, I might have to live with it, but I'd really rather not. I don't know. It just doesn't look like all that natural of a distribution. I'd like a lot more randomness to it. Now, what I can get, I don't know. Depends on what you can find and what you can make work here. Rotation over lifetime. Let's give this one a shot. Turn these guys on. Okay, angular velocity. Let's kick it up. That still doesn't seem like much, does it? It seems like they're turning really slowly. I'm really very surprised. I'll say I have a 0 on there. Oops. Okay. Yeah, something's not. Oh, some of them are spinning hard. Yeah, all right. That was better. All right, so we're getting closer. I mean, this is the way you do it. You just keep messing with that. Now, I'm not happy with, how spread out they are. I would like something a lot more concentrated. I mean, so that's what I had in my mind. How would I deal with that? Well, probably under emission, right? Remember, okay, and again, now they split out the shape. It's probably the shape, okay? So here you have some size stuff, right? Like maybe the radius, if you make the radius smaller, maybe you get more grouped up particles. All right, so that's kind of working. Now, is the angle what I want? I don't know. All right. Okay. For sure, if this is supposed to be something which is just a transient event, this kind of looping behavior, just having the thing go on forever, is not right. Now, play on awake might be right, because I'm probably going to put this in a prefab, right? And when I have a blast go off, I'm going to do an instantiate, and I'm going to place it, make sure the orientation is correct for what the application is, and then this thing should just play for, probably a very short time. So, start play, start lifetime. Duration, I guess. So a second is probably already too long. Maybe. Let's turn off looping. Okay. So now you see when I do a restart, So that would be what you'd get. Okay, it seems way too long, and the emissions should all happen at once. It should happen a lot faster. Okay, how do I get there? Right, there you go. Just keep messing with it. Maybe let's see, would it be in the shape or in the emission? Rate over time. Let's crank it up by a factor of 10 here, and let's make the lifetime a lot shorter. Let's try a quarter of a second. I like it. All right, it's getting closer. Okay, still not right. Getting closer. Okay, any questions? All right, there's a lot of buttons, so it'll take a little bit of time. Well, that's one of those things, if you end up having to do a lot of these, you get good at it. You just learn where they are. You learn what controls are effective for the kind of effects you want. All right, so let's take a quick look at what I've got in the assignment for next week. If you want to do something beyond what I put in here, doing an effect over the whole level, with a dust storm is a canned one. You try to do some rain or some snow or something like that. That would be well worth doing. Leaves falling, motes of dust, that stuff. But here's what I've got. Here's what I hope you can get all of, at least to a greater level extent. Okay, let's read through it. Okay, I'm assuming you start with an FPS camera using the FPS motion model we have and put a crosshair in it, so because some of these are shooting related. Okay, I think at this point you guys can do that pretty easily. 1, create a custom particle system with your own texture. Make it white on a transparent background, and then do the following. This is just random, just to make you go and hunt, and, get you started on customizing the particles. Make them come from a spherical emitter, make them expand as they age, get bigger, make them go from purple, they're born purple, they die orange. See what you can do. Okay? All right. 2, make an object explode when shot using the explosion from standard assets. So just to use a canned asset is an important skill, and that explosion is a pretty nice explosion. 3, make a pockmark bullet hole detail. Apply a pockmark detail to some objects when they're shot. Some objects, because often it doesn't make sense for like shrubs should not get bullet holes when you shoot at them. Okay, so and you don't have to demonstrate it on everything, but have at least some objects you can demonstrate it on. Now, additionally, if you can, see if you can do put up an impact puff, right? So some dust coming off at the impact. So a small brief puff of white smoke to the impact. And then the last one is kind of what I was thinking in my mind when I was building that particle system. So something, if you shoot something, some splinters, pebbles, other stuff may just fall down toward the ground. So another particle system to represent solid fragments. Now for both of these are more intensive, right? You not only have to make the particle system, you have to instantiate them on demand, you have to make sure their timing is right, you have to get the orientation right. And I'll be looking for all of that. I mean, I want something. I'd like something that looks totally perfectly realistic. Okay, and I realize I might have to settle, but that's what I'm looking for. Any questions? All right, cool. In that case, we're done.